Hello, welcome to another devlog for my 2D space game. Oh my god. I've been tinkering with the Steam SDK. Finally managed to upload a build and it's available in my Steam profile. It should be private, so only I have access to it, I think. But let's try installing it. Oh yeah, so I've come up with a name, Starframe Station. That took a while as well. I'm pretty happy with it. Alright. There's no chance this works on the first try, is there? That's insane. Oh my god. That's too cool. Alright, so I have a functional pipeline now. I threw this code together and we got the unit tests and then we create the executable file and then we run the Steam SDK executable with our username and password and got the script here and I'm so happy. I never thought this day would come. Oh my god. I have this Steam overlay in my game. 1 minute. 1 minute played. That's too cool. Amazing. Alright. This is a huge milestone for me. So, what's next? I want to make a checklist for things to get ready, for pretty much to finish this video and release the first playtest on Steam. So we got some stuff here to start with. We have a bug with the keybinds when we save and load. I want to improve the FPS a little. We're only at 130 there now, for example. Mineable fuel. That's a content thing. I'm thinking also we should start with a bit of fuel so that you can try out the thrusters and fly a little bit. But then we should be able to get more fuel over at the miner if we get this up and running. So there should be like fuel deposits in the boulders here. And then probably ensure that we get some reasonable resources within the range of the miner. That would make sense. Because now everything's random. I kind of like it now just to get some inspiration for before like locking things down for the initial content. But it means playtesters will have to restart until they have something they can work with. But I think that's fine. So maybe we don't have to constrain it then, because like you will also be able to move the miner. If it's in a bad spot, you can build a car, bring a torch to disconnect it from the planet, and then just lift it with like a magnet or torch it to your car, then drag it over to somewhere else and then weld it back to the planet where you have access to a fuel deposit. Or you can just build your own miner if you find the titanium and silicon that it currently costs. The camera controls are really annoying. Like I wanted to zoom in and out to where you have your mouse, but I'm not sure if it's worth doing now because it's mostly fine here. It's only annoying when you look around a lot, but I don't know. So yeah, and then yeah, the welder and torch module. So it should be like a sticks with a pointy end, I'm thinking. So that would have to be a different functionality to make it work on just one part of the shape. Well, that's fine to do in the action. That's what that's for. So, for example, imagine this is a welder, and then we hold it there, or like it's gonna have some range to it. We should probably indicate with like a circle or something, or just highlight the shapes around there. I don't know. But then you can activate the weld action, and then that's gonna connect any shapes within this radius there together. And then the torch is gonna do the same, but opposite. And then we can have like modules that have both actions. So they're like a combo module, but they could be more expensive or whatever. Anything else I want to add for the first playtest? I was thinking of hydraulics, like pistons. I'm not sure how I'll be doing that. Could have a look. And then we should, like I said, start with some fuel. Because that would like also let you put some thrusters on your car and like fly over a big boulder if there is one. Could be pretty useful. So to get the keybinds working when we save and load, it's actually two issues, I believe. First one is we need to call restore when we set the module. The set module function is called when we actually change the module, which the serializer does automatically because it's in the post init serialized attribute name. So these are the attributes the serializer sets after initializing the shape. I know I said I liked Pymunk's built-in serializer, but they're using a black list, but I want to use a white list like I'm doing here. So my system is growing on me. It's nice to have the control as well. But yeah, so that's part of it. And then because in restore, we call restore in all the actions, and then we have a restore method in the action where we set all the keybinds. This reminds me, I believe there was a bug here where we were getting duplicates, because I believe this is a list. Yeah. We don't have an action set, do we? I don't believe so. No. Would we need to? I don't think we do too much with this. Well, yeah, let's just keep it a list, and then before adding, we just make sure we're in there. We're not in there already. And then the second issue to get keybinds working was actually not so much to do with keybinds, but to do with how I changed the God mode here. Or rather, no, how I changed the debug and speed setting here. Because I used to set it to the instance, but then these values are not serialized. They're gonna be the foundation for the settings in the future, but currently all the settings are just hard-coded variables that are easy to change. But they should be stored in a separate way, like they should be stored across save files. So simply instead of setting the setting on the view instance, we just set it on the class there, and then we can use the debug keybind. For example, I was confused as to why God mode wasn't working after loading. And now I also write in the bottom left if God mode is on. But now, if we save and load, then God mode is still there. And we can still toggle it. And I believe everything is working fine now. Yeah. Alright, so that's the keybinds fixed. Now let's improve the FPS a little. I got the starting benchmark done here, 158, and we're just using this one I used in episode 4. It still works very nicely. So I profiled the run, and I saw that this was consuming 5% of the time, or like processing spent, I don't know, setting the color of the shape. So I simply now check if the color is different than we changed stuff. I feel like they should have done this on their end, but running that looks like this. So it runs 5 different times, resets the view in between, and then we get the average. Very good. Check color. Alright, and now we profile again and see what to do next. Since updating PyCharm, we now have this nice flame graph. Although it doesn't work too well for me, since, like for example on update here, it doesn't show me very specifically which one of my update methods it is, because my structure is like this. They're all named the same. So that might be a consequence or a downside of doing it this way. But I believe we can still see, like in statistics, if we check the on time here, that's how I found the coloring. But there's nothing too big here now though. It's like gravity, but I don't know. Let's check time. Oh, shape set position. Oh. Why is this being called so much? Well, it's called every frame to see what we're hovering, but is that it? Oh wait, this might be part of the overhead when we instantiate. We create all the boulders. It's a bit annoying because this is the one time when we create the world. So I think that could be ignored. So then we have gravity. 20% of the time was spent here. Not sure how to optimize that though. Yeah, you can see combine 2 is a big one too, and that's only in this setup. And another optimization in place. We got some occlusion calling going on for the new piglet shapes. I feel like they can be optimized much more though if you create like a batch for each body, but I'm not sure. There's not like you can't change the position of the entire batch, so I'm not sure what's ideal there. But this seems to make an improvement, so let's see how much exactly. Alright, got a good 55 more frames from that, but I was hoping there would be some lower hanging fruit to improve the FPS though. Let's try profiling again. I don't know, I can't find any more low-hanging fruits. So I'm just turning down the amount of boulders on the planet. It used to be 100 resting on the surface, but now I'm turning it down to 50, and that gives us this. It's kind of cheating. But I do have an idea to implement some sort of resting state. If a shape is standing on the surface, then I believe we can lock it to the planet by applying the same forces and making sure they have the exact same velocity and angular velocity. And then we can make sure the impact collider hook doesn't trigger, because that takes a lot of resources. And then we can stop applying gravity to them, because when we apply gravity to a shape that's resting on the planet, we have to apply the counter-gravity to the planet. But that's pretty complicated, and I don't want to do that now. So I'll just do this, and then move on to the next stage. See how it looks actually. Yeah, I think it's gonna be fine. One over there, there's a bunch more. That's a fun one. That's pretty cool. I like that boulder. I like that it's standing up as well. And go. I have to tip it. Yay! So, what was the next step? Start with some fuel to test thrusters. Yeah, very cool. Alright, but that's gonna be it for today. But I'll know where I should start tomorrow. So to make the game start with some fuel, I want to just add it to the starting collection, but I don't want to store fuel with all the other stuff. So I updated the modules, made a list of all the solid resources, and then that's used for the basic storage. Then it can pass through that plus control. And then for the fuel tank, we only have fuel, input, output, and pass through. Then batteries, same but for power. And then when creating the zone structure, before I had hard-coded how much each module should have here, but now this happens down here at the end. We use the distribute method that distributes the collection to anywhere that fits, and we allow partial fills. So now when we start, it looks like this. We have the battery up there, and that's fully filled with 81k power. We have a fuel tank now that's fully fueled with 5000 fuel, and the storage with the scrap and the copper. Then we can see, like, if we click on the power, we can see how the power can flow. The fuel can flow like this, and like the scrap can flow like this. Added a fuel tank to the miner here, just so we can try this out. And I've updated the spawning pool for boulders that are buried. And then we use that when we generate the buried ones, and we use the other one for the surface ones. And then we can have a third layer, right, for the asteroids. I'm pretty excited about that. Or like not asteroids, just like orbiting boulders. Yeah, that's pretty cool. But yeah, so now I removed scrap and copper from the buried ones. And I added fuel. So we're still allowing mixed resources here. So here we have a fuel and titanium one. It's a bit weird, but could be fine. Just thinking, should you be able to choose what you mine from? I believe I decided no. But what if you could? What if you could just like right click and say like just prioritize, and then in the mining action we would just prioritize that one. I don't know. But yeah, let's turn this on, see what's happening. Getting some silicon. What's that taken from? Oh yeah, I think I want to make this randomized properly though. Yeah, let's see. Mineable shapes. How do I randomize a list? Oh, shuffle. Nice. So let's shuffle take a, this is nice. You just press tab there to import automatically. Mutable sequence. Yeah, so a generator is not mutable, I believe. So let's just go like this. Oh, it shuffles in place. Okay. Yeah. Okay, cool. Nice. Let's try that quickly. So, yeah, just turn it on. See if there's even any fuel around. Yeah, there. Okay, nothing yet. Wait, let's check out the miner module. No, it can output anything and pass through anything. It only needs power input, so that should be right. And the fuel tank has a fuel tank module. Maybe it's right. Make sure it's welded too. It's not welded. Oh, because I wrote storage combined. Fuel tank combined. There we go. Whoa. When it spawns on an angle like that. Yeah, it's a bit of an issue when we spawn things. It prefers the vertices there because it points up. I use planet surface. I feel like we could do something here. So when we find a point, let's move the shape again to that point, and then we move it back up a little bit, and then we move it 90 degrees to the right or left, whatever. Move it like 500 units. And then we do this again. Wait, I don't think I need to move it though. We just have it here to get the gravity. Okay, let's see how that works. See if we can get off the freaking points. Yeah, and yeah. It looks like we're about the same distance away from that point though. Nice little fix. And we're shuffling those, and right, we're seeing if the miner can mine fuel, and now it's all connected. Let's turn it on, keep that open. Oh, we can't keep it open if we're looking around. Oh, there's no fuel around. Let's reset. There we go. Fuel, toggle on, titanium, iron, and there we go. Fuel. Nice. And that all connects to those things. It's pretty fun. Like, since it's all generalized, we could bury power in the planet, so it's using power to mine, but it could also mine power and then fill up the battery as it goes. Doesn't make much sense. But if it was fuel powered, then it could actually power itself if it digs up fuel. That does make sense. Gotten started on a welder action and just put it on a basic module for now. So now we can create a welder here costing iron and copper, and here it is. So one of the methods is calculating where the endpoint is. So I'm doing this by using the bounding radius applied to the upwards direction of the shape. That's going to be like there, because the bounding radius is going to be the diagonal for this rectangle. That's going to be like here, and then we query that position on that shape, and then we're going to get that position where it touches. And then we need to scale the radius somehow, and thought we would use the same radius that's calculated to calculate the mass. I added a new method for that there. Same way we calculate the volume using our nice class, and then I just take 50% of that hard-coded, and that seems to give a pretty nice radius there. So now the idea is like we can put it into like a corner, and then any shapes it's touching when we activate the welder should be welded together. So we can do it, oh, we're gonna have to resume the game though. It's paused at the moment. Just let it fall, and then the keybind is V there. I can press it, then we can see it just prints all the shapes in the radius now. So 4 shapes, yeah, those 4 right there. So that makes sense. So we just gotta make sure to remove itself from there. All right, we got a test scene set up here. We have 2 squares, and let's just see if we can weld them together using this welder right there. We should actually be able to just press the keybind. Okay, and now if I shift click them, they should both light up. Nice. So now they're in the same body, and I used up 2k power. One thing I don't want to happen is allowing space between, because when we weld here in the zone, they have to touch. That's how we weld. But let's see, let's put a spacer in here, make it a bit thinner, like this. Perfect. That's really getting sandwiched. And now I want to see what happens. I believe it should fail because it's gonna try to move the pieces together, but then there's gonna be overlap with this shape. So then it should fail, I think. Let's see. Got an error. Okay, so weld prep assumes they're already touching. So perhaps let's not move things around though, actually. Instead, let's just here in the welder action, we make sure that they're already touching, and then we can weld them. I think that's better. And then it would be good to highlight those shapes if possible when they're ready to be welded. Added some more code for the welder. So now if it's working, it should be coloring whatever it could weld. Oh my god, it's working. I put it on this joint. Yeah. I was just about to make the torch action, and this was my plan. I was just gonna get all the same shapes and make them single. But that's not gonna work, because we can't make the entire planet single just because there's like a thing attached here. Let's say we want to use the torch there. What should happen is we should separate them only. Like, because there might be like a thing here, there might be a thing over here, and like all sorts of things, right? So all we should do is remove that connection when we torch there. And this is reminding me of update compound, actually, that's used in make single. There we had the same issue, because if I remove that shape, then I can't just make this single, because that's gonna remove this joint. So I should only disconnect there. So I feel like we can reuse update compound, and then when it's recreating all the compound shapes, we just say combine with anything you're touching, but you're not allowed to connect with any of the shapes in this list. Here it is. So this is currently hooked up to only be working for a single body. That's true, that's what we should be using. And then here we do touching shapes. But then, no, this is called on each, right. We call this on all the shape it's touching. Right, okay. So when we disconnect there, we're gonna run it on this shape and on this shape. And then when it's traversing here and getting everything it's touching, it's gonna get these and this. But then when it's checking here, we gotta stop it. Okay, this might be a harder problem yet. Say we have these structures, and like I wanna separate the joint here. Then should these 2 red lines like disconnect, and then this is one body, and this is the other? I mean, that kind of makes sense. I'm not sure by which logic it would. For a triangle shape like this, and like we want a torch there, I don't think that's ever gonna be able to be separated. So I'm trying to think of perhaps an alternative solution. What if we only torch shapes and not connections? And then we could decide like how, based on the mass of this shape, we could decide if it's possible or not based on the size of the torch. So like the bigger the torch, the bigger thing you can detach. And then once you do that, it's gonna detach everything. You're gonna make it single. I think that might be the way to do it. Because then in this example, we do it on this one, and then this is gonna be one body, and then this is gonna be one body. Or like if we do it on this one, this is one, and then this is one. Okay, I got something working for the torch now. I made a shared class for the welder and torch. This is the difference there, just in the action. Try making a torch pointed towards the zone wall here. You see, it's gonna cost 11,000 power, and the batteries up there has 50,000 power. And since the zone is activated, then any shapes in here are connected. So like we could, we look at how the power can traverse, and then that lights up because the zone is on. If we turn it off like that, then we can see that we won't be able to activate this. So like if we toggle this, nothing's gonna happen. But now that the zone is active, let's click the keybind. There. That disconnects it. Really cool. And yeah, it didn't consume the power because it does the action first and tries to consume later. But I think that's fine. It's I don't think it will be very exploitable. Just gonna leave that as is. But yeah, let's turn on God mode and we try and like disconnect this shape maybe. I could just toggle it there. Oh, killed itself. That's really nice. So I made it able to torch shapes that are 10 times as massive or less, and that's multiplied by the efficiency as for all actions. So one idea is like what if we make the welder work the same way now, so it's more intuitive, because right now we require it to hover multiple shapes. But then what if we let it like only do a single shape like this, and then let's say we have this circle there. It's a bad example. This pipe is touching that shape, and then we weld this shape. We can weld it from anywhere, but then it's gonna weld to anything it's touching except itself. That might be more intuitive now. Now if the torch is gonna work like that. I'll just leave a comment for that. So that's pretty good. Let's make sure keep a look at everything we've committed or are about to commit. Yeah, that's good. Torch working. And that's those two done. So there's just one thing left before updating the Steam build to get the first Steam playtest up and running. Pretty excited. And that's checking out pistons. I'm not sure how they would work because we have these joints. Slide joint sounds pretty good. That's a chain thing. Could be a pin joint, groove joint, linear slide. Okay, hold on. Okay, it's a groove joint. Back to paint. Oh god, how do I make a new one? So groove joint. Right now we have a shape here. Let's just draw the car we're used to. We can join these bodies together with a pivot joint right there. That's what we're doing now. And then for like the arms like this, we put a gear joint right there connecting these two bodies, just the same as this pivot joint connects these two bodies. But then a groove joint similar to pivot joint. Okay, so it's like this, but it can slide. What? No, so it might not be a pivot joint then. It might just be a straight up slide joint. No, that's not it either. Okay, it might just be a pin joint. So like what if we have these two shapes here? Then I want to be able to separate them. Oh, like we might want to combine joints though. So perhaps a gear joint to lock the angular velocities together. That's how we do the pivot joint right now. So probably a gear joint plus a pin joint then. That should let us separate these two like this. But then I'm worried about what's in between here. But what we could do is just create some sort of dynamic shape that is resized with the space. Just fill in the void. Oh, hold on. So what if instead for this arm we put a piston here? Is that something that's possible? Wait, yes. That's just a pin joint, isn't it? Yes. So that could be done with a pin joint. So we're talking about different things here. So we could do a pin joint right there. And then just a pivot joint, and that would allow us to move the arm up and down. But then that's not quite what I was after. Like I want to be able, let's make a smaller car here. I was thinking something like this. We can extend this one out to there, and same thing here. That's a better way to draw it. Do something like that, and then it could extend up and down. It can extend like out and in and rotate. Give you a bunch of mobility there. But then I'm worried about the mass, because if we just populate the spacing with a shape, it's gonna have some mass, I think. Probably needs to. Then I don't want to create mass from nowhere. Then I guess we could like just fix that mass based on its max extended position and just enforce that mass. Yeah, it's not the biggest problem. Okay, so the filler space is a bonus. So then the question is, how do we create this piston joint? Perhaps we create like all of this as one module, but I don't really like that. because we can currently create joints on demand. Like you just select two shapes and create a powered pivot joint right there. So something similar for pistons. And it's always going to be between two bodies. So what if you just, when you click, well, you only need to know the two bodies. Perhaps say that they have to be touching, two touching bodies. Or no, I don't know. Like say you have these two shapes and you select both of them and then you say create piston. Then this could automatically be the minimum setting and you can only extend it X amount. And the direction is just from center to center. So just connect the center of the shapes. Oh, we even have a distance thing we can set here. And that's perfect. So yeah, okay. So we select these two shapes, click create piston, and that adds the gear joints so they are locked to each other. And then it also creates the pin joints. Okay, right. So the bodies, the anchor points will be the shape's local positions of that body. Yeah. Okay, I have a plan. The previous pin joint or like piston joint didn't work too well. Well, I noticed this issue when we, well, first of all, if we create a piston joint there, then the position is showing right between the center of the bodies, which is incorrect. It should be between there. But now when we extend or retract this, then the angles are locked together, but it's not staying in the straight line as I thought it would. So to fix that, we still have the pin joint. That's what makes it move. But then we limit the rotations with the rotary limit joint instead of the gear joint, and we add a groove joint, which I've just added here. And I made the max distance times 10 of the initial distance. But that's only enforced by the groove joint, not the pin joint. So the pin joint is going to try to extend beyond that. But let's see. So we go here and we create the piston joints. And now they slide like I wanted. I have an issue with the joints. I have this code to update them when we combine new shapes together or when we separate shapes. We call this function. And I'm using the state a lot. So now I'm trying to make this work for additional joints and it's getting very messy and not even sure it's gonna work. Ideally, we would just define how a joint is recreated in its own class. I think that would be much cleaner. So then the code would be something more like, what if we just create the new joint? So joint dot maybe update joints, and then we just go old bodies and new bodies, and then we put all this logic below here into this. I think that's gonna make more sense. This feels much better. To create the combined joints, I converted them to use functions directly here, and then we can use each joint's create method, and these create methods can have any signature, because I naively thought we could use this signature for all of them. I kind of messed it up, but then yeah, this is much better. And then we also can define update joint and position for all the joints. Not all of them have an update joint method yet, but for example, for the pivot joint, we call update joint when we combine a shape to a body that has a joint, because we got to make sure all the configurations stay the same. And we also call it when we split a shape apart from a body that has a joint. And depending on the joint, we gotta do different things. So for the pivot joint, one of the bodies might change. And I've created some tests for these now. So for example, this one's pretty good. So in this test, we combine these two with a joint, and then we make this one single to the right there. Well, first we combine these two, then we add the joint, then we make this one single, and then we make sure that the pivot stays with this body. I did want to make a duplicate for this, or because I do want to do the opposite, I want to make this one single and make sure it's the same thing. Let's recombine them after we make it single, and then we just make shape 2 single. And then I think just do this stuff. We can get rid of that one maybe. But yeah, it passes. Very good. Just double check this looks good. Then we get the new joint. Let's do it like this actually. Make sure it is a new joint. Ah, it isn't. Hold on. Oh, this one failed. Oh yeah, never changed this. There we go. Nice. Feels really good to get these tests in place. I also updated their structure, so now we have all the tests in a single folder, which is the norm with Python project structure. I did want to try the other structure where I put a test in each part folder here, but it was getting messy. Now they're all moved to there, and we can run this one. Yeah, run all 91 tests. Oh, we got a failure now. Oh, and we still have show on this one. Is that one of the new ones? Pivot single. Oh, it was just because it was trying to show, I think. Yeah, okay, so everything's passing. Really nice. And had some issues where when we combine the shapes, I delete the Pymunk shape, but that in turn deleted all the joints. But now I've moved deleting of the joints into the delete shape method, which is only called when we want to delete the actual shape, but we often delete the Pymunk shape, which belongs to our shape. It's all a bit confusing, but this seems to work much nicer because when we combine bodies or make them single, we update the compounds, and we don't want to delete the joints there left. We want to leave the joint deletion for this one. So this is the new place where all the updating of the joints take place. And this structure is so much nicer. It's much more decoupled, and I'm very happy about this. I feel like I'm a bit rusty. I feel like I'm getting better and better here. I wish I would have decoupled this from the start, but it is what it is. So what do we do here? Yeah, so we get all the old joints, because now we gotta respect the joint children and parents, because these combination joints down here, like the piston joints are 3 joints, and the pivot gear joint is 2 joints. The pivot joint is just a single. But then we gotta make sure that they are created and deleted in groups. Otherwise, we get very weird behavior. And then also, when we split them up, we gotta make sure they stick together. It's often based on the position. So I made the position for the joints use the joint parent, so they all get the same position to hopefully yield the same new bodies if they're moved. So now I'd like to add some more tests for the other joints, because I'm only testing the pivot joints so far. Alright, all tests are passing. Made some more tests for the piston joint and the pivot gear joint. I filled out all the methods for all the different joints. We have update, joint, and pause, and create, and I made them all explicit. I think that's more intuitive. That means we have some repeating code like these two. This one and this one are the same, for example. But I think it's okay. It's pretty clean. It's gonna be more intuitive to change now. Let's try out the actual survival mode. Let's see if we can tell that it's good now. So we had issues with, like for example, piston joints. Then we can control those with these keys. And then we want to attach like a circle here. And then want it to stay the same. Yes. Detaching it. Nice. So this looks much better. I think it's ready to be play tested now. It is 2 days later, and I've done a lot of playtesting. That's gonna be a separate video, and there are still a few things that I found that I want to fix before publishing the first public playtest. So these are the issues I wrote down while editing the clip until this point. And this one I definitely want to do, a new game button, so you don't have to restart the game every time you get a new save, especially now that everything is random when the game starts. This one is not necessary. Resting shapes on planets, that's an optimization thing. We don't need to push the game that much yet. Camera controls, really it's clunky with a right click to focus, but it works. Don't need that yet. It's all about the minimal viable product here. I'm afraid of scope creep, and just want to get something out there to get some actual feedback and battle my inner perfectionist a bit. So I think the camera is okay. There was an annoying menu load bug where, like, after you load the game, the menu disappears, but you can still click it when it's invisible. That was very strange. I had to press escape a bunch of times to get rid of it properly. So that needs to be fixed. Weld single shape to anything it's touching. Also not required. But the welding and torching outside of the zone is pretty clunky. But I do believe there are some other options for that as well. But one thing that we do need to solve, maybe not for this playtest, is being able to easily connect. Like, imagine you have a charged battery out in the field and you want to go there with your car and charge it up. But currently you have to bring out a welder and weld your car to the battery and then torch it to disconnect, and that's not fun. So there's got to be a better way to connect shapes. So like in Space Engineers we have connectors. Similarly in Kerbal Space Program we have docking ports. So that's a potentially new module to create, but that's also not needed now, I think. And then piston filler shape, because there was some instability issues with the pistons I found when playtesting, especially if you connect multiple pivots and then like a piston at the end, or like then another pivot joint. created this very unstable contraptions, understandably. Like it's a very unnatural structure, and yeah, like we had this issue where it's oscillating out of control, and filling the shapes might help with that, and also you can make it look a bit better. It will also prevent you from like being able to exploit pistons, since you're just creating an invisible gap, and then you can drive through it or whatever. Also not needed. So these are the only two things I want to fix. All right, we now have a new game button that we can press to reload with a new scenario. See those two boulders to the left there, and new game, and it's something else. But to achieve this new game, I just threw the entire setup code in its own function, and then we pass that to the app as the setup function, and just have a new game method that we call there, and then we create the button to call that one. Oh well, this was the easiest fix ever. I have this close parameter for the buttons, and I can just set that to true and do the same when we load a save right there. Not the most proper solution, like ideally the menus would be cleaned up when we reload, but this is fine. New game, and I cannot click it again. And same when we load, you can click there and works perfectly. And here's a little sneak peek of what I've been up to in the in my first playtest. Alright, so that fixes these issues right there. Alright, the playtest has been updated. You can see the link in the description below. Please enjoy and give me any feedback you feel like.